Lester Martin, and I work at a company called Starburst. We're a Trino maintainer, Trino additional build on top of software. But today I am going to just give an overview. I'm going to break it into three parts. An overview on Apache Spark. First one will be the kind of like this from the clouds looking down level. I have a quick slide in there, a little bit about me. You're welcome to take a look at lestermartin.blog. If you want to find out more, reach out to contact me or right here in video comments. Any place that you want to reach out, I'd be glad to connect with you. But I'm going to break these three videos, as I mentioned, into these three chunks on the right. From 20,000 feet on the surface and below the waterline. There are a lot of intro Spark sessions, and I thought, that ain't more perfect. Let's do a Lester one. That's a software person's mindset. So let's jump on in and see what we got here from that magical 20,000 feet. Now, if you're in the metric system, I'll let you go figure that out yourself. I think that's going to be about 4 miles. Of course, you're going to go, what's a mile? Okay, we're having a little fun with there. All right, 20,000 feet, the origins. Where did all this Spark stuff come from, and what can it do for us? Well, in fairness, Spark was created because of machine learning. Machine learning was around, been around a long time, and what often has happened in the earliest of days, people got some point where maybe their data sets were so big, they were bigger than the machines they had. They would vertically scale these machines, and then what did they have to do if they couldn't afford or couldn't build a bigger machine? They'd have to start doing sample sizes of their data set, and they didn't like the results because you might get different results from sample 1 and sample 2. Then magically, this beautiful framework called Apache Hadoop showed up about 20 years ago or so, and cool frameworks like Mahout and others started saying, hey, we can do those machine learning algorithms at scale. We can run this big cluster. And really the only problem that people had with that, they love an answer, a better answer, but they just didn't like to wait all the time. So sometimes those were long running jobs. So our good friends over there at UC Berkeley in the Amp Labs kind of little section there said, let's do something, probably for their, academic research and stuff, and then realized they could make some money off of it. And they built a better MapReduce engine that actually did fundamentally the same things that Hadoop was doing, except that they kept processes alive, and they magically said, you know what if we can cache these? So back to the very beginning, we couldn't put them in memory, but if you had a bunch of machines, we probably can. And that's going to make a huge difference when we do regression. We go back and read those, because those machine learning algorithms that they brought a whole bunch of them over to make sure they run at size and scale, all of a sudden would shine and go really fast, or 100x or even more faster, if we can keep that stuff in memory and we don't tear down processes and rebuild them. So again, just like I rebuilt an intro slide, that's what happened to Spark. We could have said maybe you grow up Hadoop, but in some ways we made a better Hadoop, one would argue. So that's the origin, but if I had to say in a nutshell, it's a cluster-based, general purpose data processing engine. There you go. It's a framework that says you bring your logic, you bring your code, your special sauce, and I will help you run that at size and scale. So the machine learning algorithms weren't created by Spark. They were like, hey, how do I run them in a big cluster? Same thing. You might just have a transformation job that you want to say, hey, it takes a long time to start from the top and go to the bottom. Parallelize that for me. So it takes that away from us, much like Hadoop also tried to do for us. And it tackles a variety of pretty prevalent, normal workloads out there. Batch, we've kind of been suggesting ML, of course. Structured data sets around there. That's really important. And then you see a couple others at the bottom. Graph computation, I don't spend a lot of time in that, but it's very interesting technology. And then, of course, just evolution of batch starts to become streaming ingestion, especially when it's a batch to do new data sets that are arriving. So there we go. And the use cases are the usual suspects. You line them up. Anything you can think about that you need to process your data on, but at size and scale, we probably got you covered. And of course, most of this is the web-based things that we think about, from the Netflixes of the world and the Amazons and a lot over the last 10, 20, 30 years, as well as critically important activities here. For a lot of people, this is just something they do transformation jobs in, or interactive analysis, or even batch analysis, building aggregates and rolling things up for us. All right. Keep going from that 20,000 foot. The reality is this framework, and I said like Trino, again, I mentioned it, I work for Starburst. I love open source Trino SQL engine, but like Trino and other systems out there, Spark can access information from a lot of different sources. Period. Full stop. Easy statement. But the real special sauce of Spark and Trino and other distributed data lake analytics frameworks really center around, hey, I got a data lake. I got a repository or a bunch of different repositories. I got a bunch of files in there, hopefully of open kind of file formats. I've got maybe table formats that apply schema to those files, etc. And those logos should make a little bit of sense as you see there. So it's going to perform better here because it was built for this kind of environment, but absolutely there's optionality to bring in other additional information. Often it's more like supplementary additional information to kind of help things work there. You can't have a 20,000 foot presentation without kind of showing the classical kind of block diagram. So let's just hit on it and talk about it. I think it'll make a little bit of sense here, hopefully. In the middle, down the bottom, I got this notion, Spark Core, the core libraries that make all this work. And then the core client API that lets you work with it. So you can bring your client, you can write software in a variety of languages, not 100, a handful, and you see on top there. Python is probably the current big winner on 2025 that we see today. But there are others that are still out there, and Scala still, there are others that you can use for sure. Python gets a lot of traction nowadays. But what's interesting here is it is a library. I said it's a cluster-based framework, but it does need a runtime environment. So the smart folks that I had a little fun with, the smart folks at Berkeley built all this, but they realized there were already some decent resource manager software out there. Kubernetes, a very popular one nowadays, but even classics like Hadoop's, yet another resource negotiator, were great things to run this. So they didn't rebuild that. Kudos to them. All right, so there's our core. We got this RDD, Resilient Distributed Dataset API. I'm going to show you a little bit of code. And you're going to see why pretty quickly that somewhere along there, someone realized, you know what, we're doing a lot of structured processing in a framework that's not built for unstructured, but doesn't require structure. So these RDD data sets definitely often had structure, but the API didn't help you work with it. You had to kind of own that yourself. So RDDs plus some schema gave us a nicer API for business-friendly, structure-enabled data sets, gave us a much more realistic API, and then it built more features or functions that align to, okay, I've got structured data, what do I do with it? And I'll show you both of those APIs in this and then the subsequent videos as well. Now, I said a few moments ago that you need a good wide set of workloads. There they are. There's that GraphX, that graphical graph processing I mentioned. I don't know a lot about it. I don't use it, but boy, when I look at it, it's pretty interesting and cool. So I would do a little Googling to find that out from somebody else. But the other stuff there, MLlib, the machine learning library, I waited till now, even though it was the kind of the origin story to put it on there, because it actually started out based on the RDD API. So you had RDDs, you had MLlib. In fact, you had that long before you had data frames. But once data frames got going, it got very popular, and that framework was kind of rewritten to work with that framework. And then eventually the lower RDD-based one still out there, but it's highly deprecated. And there's also a streaming framework. You'll see later, this is a micro batch framework. So it actually lets us write the same kind of static code or bounded data set processing with unbounded data. But again, just like the little asterisk says, there is an RDD-based one, originally called Spark Streaming. This one's called Structured Streaming. They're both out there, but we don't want to talk about them. It's 2025. So if you inherited it, great. But if you're starting from scratch, you can just, for the most part, ignore that and step along. Now, that is probably where the ecosystem slide usually ends for most folks. I went in to add a couple more things because people want to write SQL and only SQL. You're going to see in my data frames conversation that you can still write SQL, absolutely, in that API, but you kind of embed it. You're like, hey, I got this Python API has a function called SQL, and then you pass it a SQL statement. And, good old data analysts don't want to do that. They just want to write the SQL statement. I don't blame them. They don't want to worry about row concatenate this row with that row, some silly stuff that's syntaxy. So the reality is Apache Spark does offer a way to spin up something that kind of looks and smells like a database. It's based on, highly based on, if not totally based on, Apache Hive's concept called a thrift server, sometimes referred to as Hive Server 2, or probably more often referred to Hive Server 2. And then ODBC, JDBC clients can connect. Now this is purposely dimmed out on the client APIs, and the green's a little dim because for an Apache Spark, you're probably not going to use this much. Probably the resiliency, the scalability, the robustness that you're looking for probably isn't there. But if you're using a third party, and I'll just go ahead and say, if you're using Databricks, they obviously are going to tackle something like I think they call Databricks SQL warehouse or the Databricks warehouse, whatever it is, that you can just come and write SQL statements. What is it really doing? Well, it's intercepting that and writing a piece of code that says, hey, call this SQL method, and so it's the same code you would write yourself, but just giving you a little bit of abstraction to that. So that's important. That's cool. And it's worth calling out. And absolutely, it's worth calling out that this ecosystem, while the core, no new core workload management concepts have shown up of recent, I would say in the Apache world, the Apache Spark world, they did offer up something called Pandas on Spark. It actually sits on top of Spark Data Frame API. And the reality here is there are a bunch of Data Frame APIs out there. Pandas is one that a lot of people consider maybe one of the base ones. They're slightly different, and the reality is you can build Spark SQL, aka data frames, that blue bar applications that also work with Pandas, but you're kind of like exchanging things back and forth a little bit. So this was an effort to maybe target those Python, heavy Panda users that maybe haven't got into Spark yet, making the water a little bit easier for them to step into the water a little warmer, not so cold. The waves are a little bit down. Where will it go? We'll see as we go along. But I would say from most people today, at least, we're still going to probably use the core Spark SQL data frame. And again, I'll show you some code and some examples of what all that looks like. So there you go. That's our ecosystem slide. All right, next video is going to be called On the Surface. I hope to see you there.